Right, I'm making this video to explain a bit on this question because I found that some of you are not very clear about this question as an assignment yesterday. So we have a case here where we have two tension, TB and TC. Okay, and there's a load here, or the weight here, which is W of 736 Newton. So the idea here is that these two cable, they're actually acting together to lift the weight, and at this moment it's equilibrium, or they are being lifted up at a constant velocity. So I say that because the two forces, they are not 90 degrees, therefore we cannot use the right angle triangle rules. Therefore we need to use another method, which is the vector resolving. So the alternative to this is actually form a closed polygon and use the sine rule. So let me draw out the closed polygon first. So that is the W, and that's the TC. Some of you use the sine rule, that's why I also emphasize to those who are not using who are not aware of this, so that you have an alternative solution. Okay, so I guess you have some practice on how to use the sine rule, or how to form the vector diagram in the practical that we have in class before. So this angle here is between the weight and also the TC. So weight and TC, you can put the weight here, line of the weight here, and then you can find that this angle is actually the complementary of the 60 of the 90 degrees, which is 90 minus 30, that is 60 here. And then similarly for angle between the TB and also the weight, you can assume the weight is here, and then we're looking for this. So because it's 50 on the other side, so here we should be 40. And then this is angle between the TB and the TC. So what you can do for this is you can extend this, and then there's the 30 degrees here. So there's the 30 degrees here. So 30 degree plus 50 degree, 50 degree, 30 degree, that should give you an 80. And total is 180, so it does not violate the rules. That means nothing wrong with that. So let's just start with the sine rule, since we are talking about this. So sine rule tells us that W over sine 80 equals to TB over sine 60 also equals to TC over sine 40. And based on this, since we already know the weight is 736 Newton, then we can find the TB and the TC quite easily actually. Whereas if you use the vector resolving method, so vector resolving method, so first thing you have to find the balance is the vertical component. Okay, we need two equations here. This is the first one, TB vertical, TC vertical, and the weight here. So this TBV and TCV, they should be acting together to balance the W. So that's TBV plus TCV equals to W. So I guess you know how to write it in terms of TB and also TC and trigonometric function. So I'm not going to elaborate here. And we need to also form another equation using the horizontal forces for a component. So TBH and TCH. Force, horizontal component of the force TB, horizontal component of the force TC. They should balance left and right, so that the crate or the load doesn't swing left or right. So once we got that, that's our second equation. So using these two equations, then you should be able to find the answer. Alternatively, you can use the sine rule. Okay, let me know if there's any other problem.